But are you able to see the slides?
Yes, ma'am.
Okay. So today we are going to start with the next component of Hadoop, that is Hive. So we have been discussing about the Hadoop MapReduce, and we know since we are working on the big data and we have to handle the large amount of data in terms of both the storage as well as processing. So as we discussed in the last class when we were working on PIC, who developed the PIC? Yes, which company developed the PIC? Anybody? Anyone who can tell me which company developed the PIC? What is the purpose of developing PIC? Just in one line, anybody can tell me what is the goal of the development of PIC?
Ma'am, Pig helps to reduce dependency on other programming languages, Java or Python. It's easier to
Absolutely.
work in Pig.
Absolutely. Like PIC works on top of the MapReduce framework and do the computations by just writing the queries, right? So SQL-like queries that we are doing, basically that is, you can say, procedural language that we write load statements and such kind of operators we use when we have to work with that PEG. So similar to PEG, as I told you in the last few classes also, the development of PEG and the development of Hive, it took place parallelly. So at one end, the Google was, struggling to process the large amount of data, and then they developed the PEG. And similarly, you can say during the same period, your Facebook was also struggling to handle the various data, the large amount of data that it had, and processing of that particular data. So, in order to handle the terabytes of data, you know how many Facebook users are there, right? Each and every person on earth is on the Facebook, right? So now in order to handle this large amount of data and to process those queries which are coming up, because we have not many millions of users are when they are opening the Facebook. So as soon as you log into the Facebook, you should understand that the query starts processing. When you log in, what is this? So there is a query that needs to be processed. Let's start from where username is equal to this, password is equal to this. So that means a query is being fired into the database and it is comparing the username and the password of the user. And after that only you are able to get that Facebook page, right? So the query processing task is happening over there. So now, and we are, you can say the billions and billions of users are firing these queries simultaneously. So after the login, again when we are writing, when we are liking something, right? So that like data is also being stored in the Facebook. When you are writing some post, the data is also being stored. So when you are getting some information, that means you are reading it. So the select queries are being executed. So update queries, insert queries, all such queries are happening over there. Now, in order to do such kind of, you can say the data storage, so a warehousing solution was required for in order to handle the you can say the MapReduce framework. See, first of all, when they faced the problem because they were working on the Oracle solutions, right? So they were not able to deal with such kind of you can say the large amount of data. They switched over from the existing transactional system to the MapReduce framework, that is Hadoop. But working on the MapReduce framework, that was not easy, as we have seen that we need to for doing any kind of data analytics, we need to execute and the large number of you can say we need to write the so much of code in the different language programming languages. And then you can say in order to overcome this particular problem, that we want to store the data in the MapReduce framework only, but we want to get rid of all the other problems which are associated while storing that particular data. So in order to get rid of those problems, so and in order to you can say provide the fast access to the users, the Hive was developed by the Facebook. So in order to, so when they were struggling with the problem of storing the terabytes of data, so they moved over, they developed their own language that they call it, you can say they developed their own tool that is called as Hive. So basically Hive is a warehousing solution where you can say, and it is based on MapReduce framework. So you can say when we compare it to the other SQL solutions, like we have the MySQL, we have the Microsoft SQL, we have Oracle, or in all these you can see the databases, the complete data is stored in the form of tables, and ultimately it is in the form of tables only, right? We have a database, and within the database we are creating the files. So we don't have a file system like file system similar to that of MapReduce framework. But when we are working on the Hive, you can say it is like a kind of amalgamation where we are getting the benefit of both. Since we are already used to working on the SQL-like databases, and we know how to file the queries, so the Hive is being created to, you can say, query language is being provided, which you write more or less similar to the SQL query language, but you can say but the underlying architecture is your Hadoop MapReduce framework. So you are taking the advantage that at the user level, the users don't have to learn anything. Users don't; they are able to process the complete task at a faster pace as compared to working on directly over the Hadoop. So today we are going to discuss why Hive, why Hive we have already discussed. So what is Hive? Then what is the Hive data model, Hive architecture, Hive query language, then Hive's serialization, deserializations, then pros and cons, and then how when we compare, we can compare the pros and cons of the Hive versus pigs, and then graphs. So what is the data and what kind of challenges data analysts face? The data explosion, as I have told you, the terabytes of data has been generated, and Facebook was struggling in order to handle such kind of data. And in order to solve this problem of storing this large amount of data, the MapReduce solutions, they were able to first they switch over to the Hadoop MapReduce, a system for the parallelization of the data and for the storage and the parallelization processing. And then they had to move because they had to develop their own tool because Hadoop MapReduce was Java intensive. So in order to get rid of this particular problem, they just thought of developing a new solution which they named as Hive, right? So this is the logo for the Hive. So basically, you can say Hive is based on these four key principles. One is it defines SQL-like query language, as I've told you, because for the you can say for the last more than 70 years, people are working in the SQL-like languages. And the first thing that we learn, still we are teaching the DBMS, we are teaching the MS Access and MySQL, the first thing that we come across. So, which is used for working in the transactional databases. So people are used to the SQL-like query language. So the Hive is also based, the query language that is developed for the working with the Hive is more or less similar to the SQL SQL. So along with that, it also provides, like in the page, we also had an option that if the operators are not available in the Hive, then we can write the user-defined functions. So here also we have, you can say, the programmers are provided the plugins for custom mappers and the reducers. That means you can create your own mappers as well as the reducers, and you can then say use include them into your Hive and then work upon them. Then it is based on data warehouse infrastructure, so we can store large amount of data, and along with that the storage, so we can perform the online analytical processing. See the Oracle, your MySQL, SQL Server, all these systems we call them OLTP systems. They are online transaction processing systems, but your Hive is an online analytical processing system where we can perform the queries at the go, and we can perform all the business analysis at a very faster pace as compared to the existing database systems that we have. Then it provides tools to enable easy data ETL, that is extraction, loading, and transformation of the data. So we can it has tools with the help of which we can do all the tasks which are required for the mining and processing of data, or performing any kind of data analytics, any kind of business intelligence, right? So you can see Hive is associated with a large number of intelligent tools which help us in, which help you can say the data scientists to perform the task at a faster pace. So let us see what is there in the framework of, you can say, when we are working with the Hive query language, how it is going to map and how the underlying infrastructure will be working. The MapReduce task. So let us say that your count is the name of the, you can say, uh, aggregate operator, and you want to see the count of the first column, right? So then this query is being fired to the MapReduce framework, where we have, you can say, we have different your Hive for working with Hive. So as a Java as a client to the Hive, you can use two interfaces. Either you can write the scripting, sorry, the query language using the shell, that we call it as a command line interface, or you can use the web user interface, which is a graphical user interface provided by the Hive, so that you can work on that. Like if you all have worked in the MySQL, in the MySQL also we can work. Either you can work in the shell, right, in the command line interface, or you can work with a graphical user interface, that it becomes easy for you to do the task of writing the queries on the execution of the queries, right? So after the, you can say, after passing this query, what happens is the output is given to the user. So the output is given to the user. It may be whatever is the output, it is being processed, and that for that particular processing, what we have the driver, which includes compiler, optimizer, executor. Then we have a Metastore. Then here you can see, along with that, what we have: JDBC, ODBC, and the thrift server. So let us understand the role of each and every component of the Hive framework. So this is how the query is being processed. When you fire a query from the shell, it goes to the Hive engine. So there we have the compiler, optimizer, and executor. They are playing their role, and after that, the output is being provided to the shell or the graphical user interface itself, the one which you are using to process your query. So the complete data in the Hive model is divided into, you can see it is organized in the form of tables, partitions, and the buckets. So what is table? Table is same your the complete relational database tables in that you have been creating using the MySQL or MS Access. But each since in the see, when we create the table, it is you can say it is in the form of table only when we are working with the MySQL or any other transactional database. But when we are working with the Hive, the table is basically each table corresponds to one directory in the HDFS. So that means when we will be creating one table, one directory will be created in the HDFS, and the complete data in the table that will be stored in this particular directory of the HDFS. And so the complete data is serialized, and then it is stored as the files. So the tables now they are stored in the form of files in within the directory of the HDFS. So Hive basically it is having the built-in serialization, which supports both the compression as well as the deserialization. And along with that, we have the option that we can specify the custom serialization as well as the deserialization also. The terms which we are coming across, we will be discussing them in detail later on, right? So the second thing is that partitions. So what are partitions? That each table can be broken into partitions, and partitions determine the distribution of the data within the directories. Let us say that we have created one table of the country which stores the data of the states. So let us say that we have for 28 states in India, and we have created a table of some information about our country, and then we have all the information with respect to the states. Like let us say we are talking about the voting counts of the parties and all that information is there. And so we can create the partition So we can create the partition of this particular information that is there in the table on the basis of states itself. So that means we are going to, if there are 28 states, that means we are going to have 28 partitions. So all these partitions will be stored in the within the, that means within the, let us say within one folder, the name of the first folder is, let us say, the India, right? So that is the name of the table. So within India, we are going to have 28 subdirectories. So because we have created the partition on the basis of the state, which is, if you can say, and we have 28 states in this particular table. So accordingly, the number of partitions will be created, or the number of subdirectories will be created within this particular directory of that is and the main directory is the name of the table itself, or the table itself. So a simple query, which is used, which can be used as the Hive query language. So for creating the partitions is like create table sales, like we have a sales table. Sale ID is int, amount is in the form of float. Partitioned by is you can say the query, the structure, or you can say the name that is used for creating the partitions. Then country, string, year, in. So we are creating the partition on the basis of the country, year, and a month. So each partition will be split out in different folders like sales, country is equal to US, then year 2012, and month is equal to 12. So here you can say the partitions, the way they are created. So in the Hive phase, what we have sales data. Within the sales, what we have created, the two side directories are created. One is on the basis of the country US, and another is on the basis of country Canada. And then within that particular directory, for the subdirectories are created on the basis of the year and like 2012, 2015. So whatever data is there. So you can say in the complete data, when we are creating the partition of a particular table, so all the data is aligned or deserialized uh, as per your requirement, and that you have specified in the query that you have written using the Hive query language, as shown over here. So this is basically, you see, partitions are basically very popular when we are working with the distributed databases, because in that case, the partitions help in the fast query processing. So partitions may be created. Let us say you want some information from this from the X state. Let us say you want information about the UP state only. So you need not go to the complete table, or you need not explore all the other directories. You will be directly moving towards the UP state directory, and you will be fetching the information rather than going through each and every row. So this you can say if there were 28 states, the processing time is, or a particular query is reduced to 1 by 28 when the partitions are being done. Similarly, we can take another example. Let us say the partitions are created. Let us create the partitions on the basis of the names of the students which are there in GIIT. So we have created the partitions. Let us say all the students whose names are there in the alphabet A to E, they are in one, then E to G, and they are in another partition. So like that, when some queries is being fired, and let us say we have to search some information for a person named Ayush. So we know this person, because his name starts with the alphabet A, so he will be there in the partition, first partition. So we will be directly moved, the query will be directly fired towards that particular, directed towards that particular database only, and so which helps in the fast query processing. So in all the majority of the large databases, the cloud databases, for handling the large amount of data and for fast query processing, the partitioning is being widely used by all the major companies. So then we have the buckets. So data in each bucket is partitioned into buckets also. So buckets also play a very important role. See, along with the partitioning, along with the we can say the partitioning, buckets are also used widely in the distributed databases. So here in the buckets, what do we do? See, rather than see in the partitioning, you can say the rows are being partitioned into different databases. into directories, or the complete data is divided on the basis of the rows. But in case of buckets, you can say the buckets are usually created, you can say, on the basis of the columns, let us say. So if the, let us say, you have a certain database, or you have a certain application where you have stored, let us say, 100 attributes of the users. Now out of 100 attributes, there are only 10 attributes which are accessed more frequently as compared to the others. So what do? We can create a bucket of we can create one bucket of all those 10 attributes together, and we can put the other attributes in the other buckets, so that whenever the queries, because most of the queries are being fired for the same this particular X bucket, so we know that only these 10 attributes are required to be fetched, so we will be directly fetching that particular bucket and providing the information to the user. So that's the reason that bucketing is being also widely used depending upon the kind of application requirements. So basically, these buckets are, you can say that, when data in each partition is divided into the buckets and based on the hash functions of the column, right? So you can say your buckets are created on the basis of the hash, right? So like each column mode number of buckets is equal to bucket number. So to each column, a bucket number is being assigned. So each bucket is stored in a file in the partition directory. Then, along with the partitioning and the bucketing and the data models, so let us understand the architecture of the Hive now. So in the Hive architecture, as we have seen, we have external interfaces like CLI, Web User Interface, JDBC. So basically, you know, CLI is the command level interface. That means the shell where we write the Hive. We are going to write the Hive queries. Web UI is the web user interface through which we can, or you can say it is a graphical user interface through which we are going to perform the query executions. Then JDBC. JDBC is basically provided that, see, because it has a mechanism that we can write our own customized mappers and reducers, and in order to handle those customized mappers and reducers, we will be requiring a JDBC, because the program, if it is written in Java, then we require JDBC's Java database connectivity, which is required. So this driver is JDBC drivers are required in order to establish a communication between the Java program and the databases, underlying databases. Similarly, we have the ODBC drivers, which are responsible for establishing a connection between the APIs which use the ODBC. And along with you can say along with all these things, we have a thrift server. Basically, since the thrift servers are basically the closed language service providers, that means if we want to have a remote access to any of the languages that somebody wants to communicate in a different languages, like we can work with Python, we can work with the Java, we'll work with Ruby and other ODBC programming interfaces also. So Thrift server helps in performing all those cross language service tasks. So Thrift servers, it is responsible for establishing those communications. Then we have the Metastore. So since all these, as because we are working in the Hadoop MapReduce environment, and we require all the metadata about the data that we have stored in the tables. So your Metastore is all the metadata about the Hive tables, partitions, and all such related data is basically stored in the Metastore. And then what we have is the driver, which is the brain of the Hive, so which is actually responsible for performing all the compilation, optimization, and the execution. So you can say your compiler, what does it do? Compiler will convert all the Hive query language task into the direct acyclic graphs. So these direct acyclic graphs, these are optimized using the optimizer, right, wherever. So in the task of optimization is a merging, splitting, as we have already discussed. And then the execution engine. Execution engine is responsible for converting the, you can see, the direct acyclic graph, the instructions that we have received, they are converted into the MapReduce task, and the MapReduce tasks are then processed using the execution agent, and you can see that over here the MapReduce task. There we have a job tracker, name node, data node, and all these things we have already discussed. So on top of that, now you can see there is a level of abstraction that on top of the Hadoop, what we have Hive, and we interact with the Hive, and Hive itself at the back end is interacting with the Hadoop and processing all that task that is and making the things simpler for the end users. So as we have already discussed, that your thrift server, it is responsible for the cross language and for handling the any kind of clients which are written in Java or C++, PHP, Perl, any kind of script that you want to write. So thrift server is there that we don't have to do anything. We will be just working on at our end, and the backend task is completely taken over, that if something is something the client is writing anything and that is in Java language or C++ language, how to handle that, all that is being handled by the script server itself. Then in the Metastore, as I've explained it to you, that in you can see the complete data is stored. You can see the database and the namespace of in the Metastore, the metadata information is being stored, and the metadata information is like your namespace of the tables, list of column types, honor storage, then partition information like the columns and the sorts and the storage. So anything that is related to whatever tasks are being done by the user, like what all tables you have created, what all databases you have created within a particular table, how many partitions have been created and how many buckets have been created, what are those buckets. So all those information is stored in the Metastore. So from here only, whenever some user is firing the query, this information is you can say retrieved from the Metastore itself. Then from here it is being decided that which particular partition will be accessed in order to handle this a particular query. So and then the task becomes easier because that query is then directed to that particular database, and then the results are being shown to the user. So your driver will maintain the life cycle of the complete Hive query language statements. Compiler will compile into acyclic graph of the MapReduce task, and the executor will completely execute the plan based on the dependency order of the acyclic graph that has been created by the compiler. So what does the compiler do? So it is the various tasks being done by the compiler convert the Hive query language into the plan for execution, and the plans can be any metadata operations like DDL statements or HDFS operations like load. Then semantic analysis is also performed by the compiler, like checking the schema, type checking, implicit type conversions, column verifications, then optimization, finding the best logical plan, like combining multiple joins in a way to reduce the number of MapReduce tasks. So all these tasks are being done by the optimizer, and then finally the physical plan generator is being generated. That is a completely generation of the direct acyclic graph of the MapReduce jobs. All these tasks are being done by the compiler itself. So let us, before going ahead, let me show you. So we will be discussing all these queries in the next class, but before that, I want to show you that how to execute. So execute the query, how to start with working with the Hive in the Cloudera. So what do? We simply have to open the terminal, and then from here you just have to write Hive. Like in the last class, I told you that when we have to work with the peg environment, so you simply have to start with the terminal in the Cloudera and start the peg, and right the grunt shell will start. And similarly over here, now you can see here we have the Hive shell. We are into the Hive shell. So this is the CLI, that is some warning is there. We can ignore this warning, and we can see that Hive CLI is deprecated and migration to Beeline is recommended. So that's fine, but we can work over here. So we write one command, one query that is describe. Let's see. Let us create few queries. One, two. Create data, show data. Field database at what's the name? BDHS. Oh, BDHS semicolon. Oh, data. Right, so it's created one database. Let us see. Show databases. So one database I have just created BDHS, and another I had created before that, that's a Shikha. So within this database we can create table, create table, ELT, oh, Hive, and salary, not mm, after that, wait a minute. Create table ID, we have to specify row format delimited and field terminated. Row format delimited. So we are going to store the data. So why I'm just looking at this particular thing is because we are going to store the data. We are going to load the data from a particular CSV file into this particular table, and then we are going to do further processing. So we are just creating a schema for that over here, right? So here you can see a little. Yeah. Oh, Hive. Uh, Limited space, and then no problem. Then what else the next thing? Terminated by right. So now describe the name of the table EMP. Right, so we created one table, and now using the describe, we are just trying to see what is there. So it has shown the structure of the table, the schema of the table, ID, salary. Right, so this is how this is just to begin with. In the next class, we will be practicing the things from the various commands that you have already see. These are the query language structures that we have studied in the, you can see the SQL query. The similar kind of query language is being developed in the Hive also. So we will be learning how to write the queries and how to do the data processing task, how to do the analysis using the query language, right? So for today, that is all. Okay.